Hello guys, welcome once more to Class Online. My name is Tutami, and in this edition we shall look at Jamb Physics 2013, question number 11 to number 15, and we shall simplify the question in a way that physics will become clear and easy to solve for you. Don't forget that if you learned something from this series, click on the like button. We have lots of content to share with you that will better help you understand physics. Now let's get to number 11 now. Number 11 says the coefficient of friction between two perfectly smooth surface is what? Now friction, this question is based on friction, right? Now friction occurs between surfaces that are not smooth. Like if you are walking on a tarred floor, there is less friction and you can fall down. And that's the reason. So friction has to do with surfaces that are not smooth. And like for this now, I have this ball rolling on the ground. This ground is smooth. So what is the friction between the ball and the ground? If the surfaces are smooth, there is no friction. It is difficult for friction to occur because friction is the force that goes against motion. So if the surfaces are smooth, it will just glide and slide, and then there will be no stopping, and that means that the friction is dead, and that means that the answer to that question is just 0 because there will be no friction. Friction can only occur between surfaces that are not smooth, as in there will be opposition. Like between my two hands, they are not very smooth, so there can be frictional force. But between surfaces that are smooth, there is 0 friction. So that's just it. Let's take out number 12. What effort will a machine of efficiency 90% apply to lift a load of 180 Newton if its effort arm is twice as long as its load arm? Now, what will be the effort? This is a machine question, and we know that for the efficiency of machine, the formula to use is what? MA over VR times 100, where MA is what? Mechanical advantage, and VR is what? Velocity ratio. So if MA is mechanical advantage and VR is velocity ratio, then times 100. This is the formula for the efficiency of a machine. Now, but the question didn't ask for mechanical advantage. It said what effort. Now, in this formula, there is no effort, but indeed, inside mechanical advantage can be broken down into load over effort, and there lies the effort. So it is under mechanical advantage, load over effort. So it will become E equals, instead of MA, it will become load over effort over VR times 100, and that is it. Now, the next is to find the effort. So I'm going to try to make the effort the subject of the formula. So I will cross multiply. It will become 100 load over effort equals efficiency times velocity ratio. That's VR. Now, therefore, I will make the effort the subject. So E is therefore going to become 100 times load over E times VR, and that is what I'll get if I cross multiply and I divide both sides by EVR. It will give me 100 times load over E times VR, and that is the effort formula. Now plug in your parameters. What's your 100? 100 remains 100. That's 100. What's your load? It's 180 Newton over what is the efficiency of the machine? 90%. So you put down 90 times what is your velocity ratio? In the question, we were not given velocity ratio, but we were told that if its effort arm is twice as long as its load arm, and you know that velocity ratio is effort arm over load arm. So therefore, the effort arm that is twice as long as the load arm is your velocity ratio. So your VR is therefore automatically 2. Okay, that is just the little trick that they played on VR, and therefore the effort will now become 100 times 180 over 90 times 2, which will become 18,000 divided by 180, and which is 100 Newton. So your effort is 100 Newton, and that is the answer to that question. Don't forget that most importantly, you must remember that anything efficiency of machine is MA over VR times 100. I'm usually asked about this part of machine, and please take note of it. Take super note of the formula. Let's go to number 13. So the answer for number 12 is C. Number 13 says calculate the work done when a force of 20 newtons stretches a spring by 50 millimeters. Now, what is the relationship between work, force, and extension of string? Do you have any idea what formula? Now, what is the work in a string or in an elastic material? Now, under the topic elasticity, we learned about spring like rubber, but we also learned at the end, we learned about stress and strain and Young modulus. but at the end we learned about work done. Now the work done in an elastic material, if I pull a rubber and I pull it now and I pull it out, how can I calculate the work I am doing? Now the formula for finding work in an elastic material is very simple. It's just 1/2 Fe, where my F is my force and my E is the extension of the spring. Okay, then the W is the work. So anything elastic material has this formula as its work, 1/2 Fe, or you can say 1/2 Ke squared. But for this question, the formula to use for finding the work of an elastic material, that's the work done in an elastic material, is 1/2 force times extension. Now 1/2 is 1/2. The force is 20 Newton. The extension is 50 millimeter, and that is a trap because length or extension can't be measured in millimeter. It should be measured in meter. So I will divide it by 1000 to move millimeter into meter. That will become 50 times 10 to the power minus 3, which is 1000. Okay. Now that's it. It is now in meter. Then cut it out. 2 divided 20 is 10. 10 times 50 times 10 to the power minus 3. 10 times 50 is 500 times 10 to the power minus 3. If you plug that in, if you work on that, if you punch it on your calculator, you'll be getting 0.5 joule. Or that means you can move 3 times backward. 1, 1, 2, and 3. 0.5 joule is the work done by that spring, and that is the answer. Don't forget the formula for anything work in an elastic material like spring or rubber. It is just 1/2 Fe, and that is just the formula. It can also be given as 1/2 Ke squared, but in this case it is 1/2 Fe, and that is the formula for work in an elastic material. Number 14 says, at what depth below the sea level would one experience a change of pressure equal to 1 atmosphere? Now, what will be the depth? If you have, now we have the density of seawater is equal to 1013 kilo. That should have been, because it is density, it should have been kilogram per meter cube. Okay, that's a mistake. Then 1 atmosphere is 1.1 times 10 to the power 5 Newton meter square. And then G, that's acceleration due to gravity, is 10 meter per second square. Now, at what depth? That we have to find depth. We are given density, right? So what do you think we will do? Now, very easy. This is what we do. You must remember that pressure, which you are given pressure in the question, is equal to density E times G, that's acceleration due to gravity, times depth or height. Now, at what depth means you have to find the depth. So that means the H will be the subject, and equals to this density, and G will come under P, that pressure. It will become H equals pressure over density times G. Okay. Now, what's the pressure in the question? 1.1 times 10 to the power 5. Okay. Over the density is 1013. Then the G is what 10. So if I saw that 1.1 times 10 to the power 5 will be what 10,100 divided by, if I multiply the one below, I'll be getting 10,130. If I divide that, I will be getting 9.97, and that is the answer to that question. It is 9.97. Actually, this is supposed to be not 10,100. There's a mistake here. It should have been 101,000. That means there's an extra zero behind this working, which I did not include in this question. Because if I move this point from here 5 times, 1, 2, there will be 3 more zeros, 3, 4, 5. And I put 2 more zeros. It should have been 3 more zeros divided by the one below, giving me 9.97 as my height meter. So the answer is just approximately 10, because approximately 9.97 is approximately 10 meter, and that is it there. The answer is 10 meter as my answer, and that's my depth. Now, don't forget that pressure is density times acceleration due to gravity times height. Don't forget that. Now, many people will say, oh, pressure is just force over area. Yes, everybody knows that, but pressure in liquid is density times what? G times H, where G is my what? Acceleration due to gravity, and my H is my depth or height. Now, and that is what I used to find height, turning the formula upside down, and that is the second formula for pressure. Please take note. Now let's go to the last question for this video. What volume of alcohol will have same mass as 4.2 meter cube of petrol? Now, density of alcohol is equal to 8.4 times 10 per 2 kilogram meters cube. Density of petrol is 7.2 times 10 per 3 kilogram meter cube. Okay, now what will now be the volume of petrol? Okay, now you can see that in this question we were giving two density, one of alcohol, one for petrol, and we're given the volume of petrol. Then we are told to find the volume of alcohol, right? So what we do now, we just do, it is an interplay between, like this man, we have a petrol and alcohol. It is an interplay between petrol and alcohol. Now look at what this man is doing. He's pouring the petrol and the alcohol into this machine, and that is what some people do. Okay, but that might not be very right. Now, but please, this question here, the reason why I could put this picture is because I'm just trying to show that it is an interplay between petrol and alcohol. Now, and they are talking about density and volume. So now, in the formula for density, there is volume, right? Now, I have to bring the density and the volume side by side. So, density is mass over volume. If I cross multiply, I will have mass equals density times volume, right? Now, they are now side by side. So now, I'll now say D1, V1 equals D2, VP, V2, sorry, where D1 is for what? Alcohol. That's density of what? Alcohol, volume of what? Alcohol equals density of petrol, volume of petrol. And therefore, I'm to find at what volume of alcohol. So I'm finding volume of alcohol, VA. And to find this VA, I'll bring this DA under this ones. So it will become VA, that volume of alcohol equals density of petrol times volume of petrol over density of alcohol. Now plug in the parameters. What is the density of petrol in the question? The density of petrol is 7.2 times 10 per 3, and that's it here. What is the volume of petrol? I was given there at 4.2. Okay, divided by what? The density of alcohol, which is 8.4 times 10 per 2. Now the next thing to do is to bring the numbers side by side. That's 10 to the power 2 below will cost 10 to the power 3. I'll have only one 10 on top. It will become 7.2 times 10 times 4.5. Okay, divided by 8.4. Okay, now multiply all the ones on top. It will become 302.4 divided by 8.4, which will give me 3.6 meter cube. And that brings me to my answer as 3.6 meter cube. Don't forget that it came from the relationship between density and volume, coming from the formula of density. I just equated density and volume, and I made it separately, D1, V1, D2, V2, and I used it to find my VA, and that is my answer. Easy peasy, right? Now that brings us to the end of this video. Don't forget, if you learned something from this video and you want to get more content from us that will better help you understand, click on like button, and straight up you will get more content from us that will make physics what anyone can do. Now until we see again, guys, take care of yourself and bye for now.